When light of any kind shines through a dense medium, it appears larger, or rather gives a greater glare, at a given distance than when it is seen through a lighter medium. This is more remarkable when the medium holds aqueous particles or vapor in solution, as in a damp or foggy atmosphere. You can see this by standing within a few yards of a street lamp and noticing the size of the light. On going away to many times the distance, the light upon the atmosphere will appear considerably larger. This phenomenon may be noticed to a greater or lesser degree at all times, but when the air is moist and vapory, it is more intense. It is evident that at sunrise and at sunset the sun's light must shine through a greater length of atmospheric air than at midday, besides which the air near the earth is both more dense and holds more watery particles in solution than the higher strata through which the sun shines at noonday, and hence the light must be dilated or magnified as well as modified in color. So the sun, as it sets towards the horizon, from a viewer's perspective on earth, simultaneously gets bigger due to the reason given above, and smaller due to the law of perspective. The net result is what you see. Notice how the distant lights have a brighter and bigger glare even though they're further away. Many contributing factors, including wavelength, diffraction, air pressure, air temperature, width of aperture, altitude, humidity, and clarity, all contribute to the net result. The amount to which the sun and moon will be magnified, due to the above reasons, and shrink due to the law of perspective, will depend on all of the above. eNature.com writes, "The moon's warm color when seen at lower angles is caused by the relatively larger amount of atmosphere through which one is observing it as compared to when the moon is right overhead. This additional atmosphere scatters the bluish component of the light of the moon, making the low-lying moon appear redder to the observer's eyes. If you look later when the moon is higher above the horizon, you'll see it appears much whiter than earlier in the evening." It does change, and the changes are mostly due to the atmosphere. So I can show you a picture of the sun setting in the desert where it's very dry, and you'll see the sun shrink and shrink into a tiny, tiny pinprick before it disappears into the horizon. And then I can show you another video of on a more over the ocean, say, on a more humid day, the sun is going to actually expand a little bit due to the atmosphere and then disappear into the horizon like a big ball, as many people have seen it. But either way that it disappears, whether it disappears into a pinprick before leaving the horizon or it expands and goes down the horizon, it's simply moving away from your perspective, as we talked about. It's not actually going down, just like a row of street lamps aren't getting shorter and shorter as they get farther and farther away from you. It's just an element of perspective.